So now what we're going to do in this video is take this Fresnel lens to focus the light on this solar cell and hopefully get more current out of it than what we normally get. So to begin with, under the lamp, the voltage isn't too bad. This is a 5-volt cell, and we have a little bit, or close to 5 volts I should say. If I use the lens though, of course we can get the voltage up. So what a Fresnel lens is, as you can see, it's flat. There's little grooves though. But what those grooves do is they make it act like a magnifying glass. So you can do the same thing with magnifying glass, but it looks like the Fresnel lens does it better. And as you probably know, magnifying glass or curved glass, whereas the Fresnel lens just has little grooves on the plastic that circle around, and so they focus light like a magnifying glass, but in a different way. So in any case, the voltage looks pretty good with the indoor light. We got a lamp over here, over the cell I should say, and now you can see we have 0.52 milliamps, so about half a milliamp, and that's with the lamp fairly close and pointed at it pretty well. Before I set this on the plastic, there you can see it went down when I tilted it a little. Makes a big difference how much it's focused towards the light. But in any case, now we'll use the Fresnel lens, and if you get too close it's going to hurt your current, as you can see there. But now as I get closer to the lamp, you can see we passed 1 milliamp. We started with about 0.5 milliamps, and generally about the best I do is about 1.1, maybe 1.2 milliamps. But as you can see, the little lens here definitely made a big difference in how much current we could get. We doubled the current with the light shining on the cell pretty good. When the cell wasn't pointing at the light as well, I was getting about 0.3 milliamps, and using the Fresnel lens, if I had it set right, I still got about 1.1, 1.2 milliamps, but that kind of makes sense. I was redirecting the light towards the cell when it wasn't pointing at the light as well. So now I turn the lamp off, and we're using the overhead light, which is it's an LED light, but it's the equivalent of a 60-watt incandescent light bulb. So it's not very bright, and it's not really pointed directly at the cell, but still, it's only about 0.03 milliamps, not much at all. And now even using the Fresnel lens, it doesn't really make any difference at all. So what I have is this larger Fresnel lens, and it's almost a foot in length. Now I get that between the ceiling light. I'll turn the light on the meter because the Fresnel lens is getting the light away from there. And now I'm over halfway towards the ceiling light, and you can see we got above, we got to 0.5 milliamps. I've been able to get 0.6 milliamps at times. I'll flip it over, and there you go. You can see I surpassed 0.6 milliamps. So again, this isn't very much. We're still dealing with less than 1 milliamp, but as you can see, without the Fresnel lens, we're only getting about 0.03, whereas with it, we're able to get up to about 0.6 without too much difficulty. So the Fresnel lens definitely makes a lot of difference. Now, of course, this is just indoors. When I had this cell in the direct sunlight, I think I had 30 milliamps coming out of that. It was about 30 milliamps. And now we're lucky indoors to get 1 milliamp, even under the lamp with the Fresnel lens. But we did prove that we can increase the current with the lenses. Let's take a look at the voltage. I forgot to do that now with the big Fresnel lens too. And turn that light on. And you can see we can actually get, we might even get 5 volts, but we can get practically 5 volts, 4.9 with the Fresnel lens versus without it only 2.5.